Hey guys, welcome back to the laboratory. In this video, we are looking at the isotopes of elements. By the end of this video, you should be able to define the term isotope, use atomic and mass numbers to calculate the number of subatomic particles in the different isotopes of an atom, and calculate the relative atomic mass of an element. So, let's go. Isotopes are different atoms of the same element. They contain an equal number of protons, but a different number of neutrons. For example, lithium can exist as lithium-6 and lithium-7. We know that the atomic number of an element is unique to each element, so this explains why both of these lithium isotopes have the same atomic number. However, each isotope has a different mass number. Because of this, we refer to isotopes using their mass numbers. This is lithium-6, as it has a mass number of 6, and this is lithium-7, as it has a mass number of 7. As both lithium isotopes have an atomic number of 3, both of these atoms contain 3 protons in their nucleus. To calculate the number of neutrons, we must subtract the atomic number from the mass number. Lithium-6 has 3 neutrons in its nucleus, and lithium-7 has 4 neutrons in its nucleus. Now that we've calculated the subatomic particles in each of these atoms, we can see that they are both isotopes of lithium, as they have the same number of protons, but a different number of neutrons. A quick side note here. If you're thorough like me, then you're probably wondering about the electrons and how they can be calculated. Remember that your atom must always be electrically neutral, meaning there must always be the same number of electrons as there are protons. So in the case of these lithium atoms, both will contain 3 electrons. The relative atomic mass is the weighted average of the masses of an element's isotopes. Now let's pause here. The relative atomic mass is not to be confused with the mass number of an element. The mass number is simply a count of the particles in the nucleus of the atom, and this will always be a whole number. The relative atomic mass is the average number of protons and neutrons for all the natural isotopes of an element, and this will always be a decimal number. Here's an example of a question you may be asked when calculating the relative atomic mass of an element. Chlorine contains 75% of chlorine-35 and 25% of chlorine-37. Calculate the relative atomic mass of chlorine. To calculate the relative atomic mass of chlorine, we can use the following formula. Next, we must substitute the formula using the information from the question. The first chlorine isotope has a mass of 35 and has an abundance of 75%. We can add this information to the first bracket in the formula. The second chlorine isotope has a mass of 37 and an abundance of 25%. This information can be added to the second bracket. The formula for this question is now complete. 2,625 plus 925 divided by 100 equals 35.5. The relative atomic mass of chlorine is 35.5. Now it's time to test your understanding of this concept. Pause the video and take your time to work through these questions. Press play once you're ready to check your answers. Let's talk through the answer to this first question. Our first bromine isotope has a mass of 79 and an abundance of 50.5%, so this information can be added to the first bracket of the formula. The second bromine isotope has a mass of 81 and an abundance of 49.5%. This information can be added to the second bracket of your formula. 3,989.5 plus 4,009.5 divided by 100 is equal to 79.99. The relative atomic mass of bromine is 80. Here's the answer for the second question of this task. How did you do? Let me know in the comment section below. Before we finish up, I wanted to share this past paper question with you. Here's an example of how you may be assessed on this particular concept. Pause the video, read the question, and take your time to answer. I'll be waiting for you on the other end with the mark scheme. As always, it's important that you make use of the information that the question has given you. The atomic number of boron is 5. Straight away, this tells us that the atoms of boron contain 5 protons. Boron exists as 2 isotopes, boron-10 and boron-11. Remember, the numbers that follow are the mass numbers. Use the information to explain why boron-10 and boron-11 are isotopes. Well, we know that an isotope is an atom of an element with the same number of protons but a different number of neutrons. All this question is asking you to do is to show that both of these isotopes reflect this concept. So, as they both have an atomic number of 5, this means that both atoms will have 5 protons. That's it. That's your first marking point. However, boron-10 has 5 neutrons and boron-11 has 6 neutrons. That's your second marking point. That's it, guys. How did you do on this one? Once again, let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!